And our next speaker is Joshua Weitz. So Joshua, you should feel free to unmute and to share screen. And Joshua is one of the founders and progenitors of a new program, relatively new program, in graduate PhD program in quantitative biosciences at Georgia Tech. He's also I'm very pleased that he's able to join us because he's been working tremendously hard on COVID. He's an expert on viruses and human system connections. And Joshua, really appreciate you taking time out from the important work that you're doing on COVID to talk to us about your experiences there in building the PhD program in quantitative biosciences. So take it away.
Okay, thank you, Lou. It's a delight to be here. I realize this is a delayed meeting. Many things have been disrupted. Can you hear me, by the way?
Yeah, just I would say speak up a little bit more. I can hear you, but
can you hear and also see the slide? Sorry, my AirPods are not working, but okay. So I'll build upon some of the themes already raised by Lou and now again by Stefano. And I'm going to try intentionally to talk about what we've done, but going beyond the sort of challenging problem that you may face at your institution when you're thinking about developing these interdisciplinary programs, when good intentioned faculty gather around and say, well, we always did it this way, as you said, Lou, and then, well, we did it that way, and you have 12 different ways, and it all sounds great, but obviously no human is going to want to enter that program or complete a program. And as much as we want to sit and talk about the right theory for the right problem, I'm going to make a claim today that even really good theory, even if you resolve that, it's not good enough. There are just many practical issues to overcome if we're really, as a community, going to expand the number of these interdisciplinary training programs, whether they're standalone PhD programs. And sorry, it seems like my Mac has decided it must update my... Hold on one second. Do you see what I'm seeing or no? Give me one.
We just saw your slides.
Okay, I'm going to get them back because my Mac decided that it must update the entire system and interrupt. Okay, there we go. It's back. It took over the whole system. So the point I'm trying to make here today is that we really need to think hard about practical, problem-centric approaches if we're going to try to expand the number of these interdisciplinary programs, whether they're standalone or they're part of certificate programs that augment the graduate student experience. So to give some context, this has been a long ride. This is a news item in Georgia Tech back in May 2015. And if you think 5 months ago is a long time, then try 5.5 years ago. And even before this, we had been working for multiple years even to get to the point that the state institution, like many of you sit at, would even approve such a thing, right? So educational innovation, however exciting it may be, is let's call it a steady process. It is rarely going to move very fast. And when we got that approval, that only meant that we could then begin to seek out students who might want to apply, right? You're throwing a party and you're not sure, is anyone going to show up? And that's always that sense that you have at every stage. And we had a vision really to try to establish this interdisciplinary graduate program to advance research and education at this interface between physical, mathematical, and biological sciences. And in our particular case, we decided to emphasize cross-scale research, really going from molecules, cells, organisms, and the environment, in particular because there were already a few of these programs out there that focus more on the cellular molecular scale, but also our faculty who were excited about the space really had strong influence and interest at these organismal physiology and ecology scales. And yes, we had molecular cellular folks as well, but it wasn't like the center mass was all there. We felt it was very important to be able to bridge across scales. So when we set off on this goal, we had an idea that around spring 2021, in other words, a few months from now, we'd be awarding our first set of PhDs. And just to give you a sense that when it was approved, there was 2 to 3 years even behind that of development, of gaining consensus and working things out, and then years to come to push this forward. So I don't mean, Stefano, you cautioned against book writing. And since I like writing books. I've written one, and I'll tell you about some others. I ignore Stefano. It's great to write books. We need more books. With all these tweets, we need long form, and it's worth it. And I would say the same thing here for this timeline. Yes, that's a decade almost of timing, but there's something quite, I will say, rewarding for the students, for the community building, for the people who are involved to see the development of something that really has a chance to last. So despite the fact that you have to know it's going to take a long time, same with book writing, I think it can be very meaningful. I assume that, Stefano, you wouldn't take it back, that you read. So yeah, there's something quite nice about it. So what happened? We had folks arrive in fall 2016. You can see this inaugural cohort, and this is upstairs in our engineering bioscience building here at Georgia Tech. And now this is where we are now. So we have multiple cohorts, and we're in the process of recruiting yet another cohort. We have 34 students, actually already have one graduate, so we are a little ahead of schedule. That's part because someone transferred in. But this is an international group, people from different kinds of backgrounds, people who came from more on the bio side or computing or engineering, people from the United States, from Mexico, Europe, Asia. So it's truly a kind of a global program that has begun to develop, intentionally so, a sense of culture. And I'll talk about that later. And of course, it's supported by faculty. So we've had to have the buy-in of many faculty spanning multiple schools across the College of Sciences. And to get there, this is where they started. There's a meme out there. I should have done how it began and how it ended. I don't know if you've seen this meme, or how's it going? I can't remember how to do it. This is how it began. This is how it's going. So we have folks who now started up. They're trying to figure out what they're going to do. And now 4 years later, we've tried to feature these in our slide, our recruiting slide, showing, first of all, what they're up to with one of our graduates and some perspective. But all of them we already have had one full graduation. We just had 2 in the fall, and the rest are planned for the spring and summer. So we're really seeing the development over time of these interdisciplinary projects. And you can see by the titles, it really spans scales. We've had multiple award winners doing impactful and interdisciplinary science. But the key is that we've tried to emphasize a culture that goes beyond the lab or group. When you're starting an interdisciplinary program, it's not as if people have always done physics, they're going to do the next logical thing, or math and then the next logical thing. We have to kind of create our own thing, a sense of home, a sense of place that students have found their people, the people that they want to talk to about science, about the problems, also how to do it. And it should extend beyond that lab or group. So we don't want them just in their lab or group, but really into a way of doing research and teaching and also doing service all at this interface. Okay. So I will try to explain a little bit of how we did that, and I'll try to break it down because it's hard, obviously, to condense all of this into a 25 or 30-minute talk, but nonetheless, I'm going to try to give you some of the themes that I hope guide our thinking. Meaning, rather than giving you every detail, I want to give you some of the themes that helps me remind me and our colleagues whether or not we're on track. And in doing so, first of all, we have to think that we are serving students. This is a graduate student program, and so we need to prioritize their needs and their career developments, which are maybe different, and almost certainly are different than our needs. I mean, there's going to be overlaps as we're doing research together, but they're going to have a particular place that they're coming from and where they're going. So first of all, who are we targeting? Yes, we are targeting undergraduates in the biosciences, but we have made a decision to look for individuals who have already begun to walk this path, who have taken steps to use an elective, to take an extra math class, or do some coding. It's not the same as being a major, but they've already shown an interest. And by doing that, and the fact they're applying, we avoid the case of saying, I think that's going to be the future, but maybe that's not part of that person's future, because there are also important needs for bench scientists, not for everyone. So by looking at people trained in the bioscience who've already taken that step and want more, we already have our interests aligned. We have a fire in the belly, as it were, for people who are excited. The other category of folks, broadly speaking, that we're targeting are those trained not in biological sciences, and that could be the physical sciences, math, computer science, and engineering. I realize that's a big group of folks, but who would like to transition to a career focusing on bioscience research. And again, we're looking at some evidence. They did that physics major, but then double majored, or had a minor, or did an internship over the summer that was very far from traditional physics or mathematics and had a clear bio interest. And again, they want more. So it's that same idea that they're seeking out more of this work at the interface. And frankly, there are very few people who have true undergraduate majors in quantitative bioscience because there just aren't so many such programs around. So we're intentionally targeting people who are signaling they're looking to create their own path in some ways. They've taken those steps, and we've tried to formalize, and as they say, clear a way. We try to clear a path for them to move ahead. In doing so, we're bringing these people together, and again, in that theme that Stefano alluded to about trying to foster cross-disciplinary interactions, we also have to have some values in mind. What are we trying to instill? And the first one really are values as us as a science program. And I will concede that one of the decisions we made, and I'll take some responsibility for making that decision stick at the outset, was that all of our homeschools are in the College of Sciences. We're a science program. It is not an engineering program, and it is not a computing program. And partly that's because we already have a terrific bioengineering program and a bioinformatics program here, which already hit at those interfaces. And our view was that we needed to look across the interface between, again, mathematics and physics and the life sciences. And those folks don't necessarily identify as bioengineers or computer scientists. To do so, that means that we think that we can make progress in translation, do meaningful work in that Pasteur's quadrant, if you will, right, where it sits at the fundamental but also applied relevance, that begins with principles, but these principles are increasingly quantitative. So we're a science program. We want to understand things that are meaningful and foundational, but we think that to do so, we have to understand the quantitative basis. But to make such progress towards that value, you have to be quantitatively trained, meaning sometimes that just means applying existing quantitative models to bioscience challenges. And for some people, that will be developing new rigorous models in the process. And finally, I think if we do both of those things, we are ensuring that those students have a future. And in fact, what I mean by future is really one where they can continue to do impactful quantitative research, whether in academia or in industry or in related fields. We have a career program that we've initiated. We just had one of my students trained in physics who kind of went this path before we had this QBIOS program, and now is working in the data science industry. But that notion of computing and project-oriented work is still obviously influencing the way that they've thrived in their career. So again, what we're trying to do here, I'll try to encapsulate this, if I can, into just one sentence. Our overall objective is to train graduate students how to reason quantitatively in the biosciences given uncertainty. In mechanism, rates, reliability of measurements. I've underlined the phrase because I think it really hits at all of the pieces. We want them to be quantitatively rigorous, but have a value set and care about the biosciences. It's not a math program for its own sake, a methods program for its own sake, but there's uncertainty. They need to be strong in computation or data analytics because it's not going to be a proof-based program per se. We have to deal with the real world, and therefore, again, means that we have to teach them skills that can be useful. And the other thing that I remind the students is that you can do it, right? That you can do it. It's going to be hard. You can do it. But now I will turn this around because I'm talking to our peer group here, and I'll say the you is the you faculty. If you want to start one of these programs, yes, you can do it, but it's going to take more than just theory, right? It's going to take more than just the good idea. There's going to be a lot of, let's call it sweat equity that you're going to have to put in to make it work. Okay, so I have tried in an essay that, I wrote this around February or March, and then COVID hit, and I realized, I had written this essay. I should look at what I wrote because I'm giving this talk again. I had developed this in part for the original timing, but I want to just highlight some of what I'm using to some extent in this 10 simple rules style of PLOS Comp Bio, 10 simple rules for developing a QBIOS graduate program. Again, with the caveat that one in that program is 10 simple rules to win a Nobel Prize. So I don't think these simple rules are always so simple. Nonetheless, I think I've tried to organize these according to a few sets. Values, theory, relationships, and a sense of place. I'm not going to go and unpack each one, but I will give, again, some highlights. How do we go beyond theory and make this happen? So first of all, it's a science program. And other folks in this audience may view this more as your need is a math program, but it's math bio, where it's really the math that's preeminent, or computation is more preeminent. But for those who want to do science, I think it's important to recognize that we have to then care about the discipline, care about both where it comes from, but also care about the global challenges we face. How are genes regulated and controlled? Why is there this problem of antibiotic resistance? Right? How can we overcome it? How do we see pathogens evolve? Can we understand the brain and signaling behavior? And what do we do about the fact that anthropogenic climate change is just threatening species and ecosystem function? These are real challenges for which my view is that quantitatively trained folks can have a real role in making an impact, both on the foundation side, but also into policies, therapies, methods, and so on. So we've tried to instill the fact that we're focusing here, this is our goal, to make a difference at some scale or across scales of living systems. And to do that, that guides our choice of how we've developed a program of study. We try to bring people together in a course that I'll describe in a moment, Foundations of Quantitative Biosciences, that I've developed, but also seminar courses, rotations that bring people together with individuals, faculty members they might not otherwise decide to work with. It also gets them out of their labs. They're not just a student with person X, but they're a member of this community. Expecting that folks will take a modeling core as well as bioscience classes, but not specifying that everyone has to take foundations of neuroscience or foundation of molecular and cellular biosciences if someone wants to be doing ecosystem-based work. They just have to take a thematically linked set of courses a la carte, and the same thing with the modeling. So we're expecting them to take some a la carte, but also building a sense of community, those asterisk courses, foundation and seminars, they all must take together. And if you look at the amount of coursework they do, I would say it's really sitting between most bio programs, which require very little coursework and almost no modeling or no modeling classes, and more math and physics programs where it's specified, there's the canon, you must take these, and then it's very hard to kind of do all this other flexible stuff. And sometimes the canon is not even relevant to the actual problems you want to work on. Okay? So what we have tried to do also is make sure we do not add time to degree. Our choice was not to take your existing discipline and add on another discipline, but to establish an independent program in which there's a unified set of courses that are the same for everyone irrespective of homeschool, and then switching into rotations and thesis initiation in year 2. And again, I think, Stefano, you alluded to this about the choice of projects, not finals. It is hard to do a qual exam for a very interdisciplinary program that's meaningful towards the program. So instead, we have a proposal which represents the oral and written parts as the required elements of that advancement to candidacy. And we put it early, because the last thing you want to do is hear in year 4 that your very smart thesis advisors have another idea of what you should have done, and you could have heard that 2 years ago. So we try to move that early in the program so that the students get this feedback, and it's meant to help them advance to do the independent research. And we use their course grades as our indicator of whether or not they've mastered the material from a foundational side. So in thinking about these set of values, which are all focused on can you make a difference in the biosciences, let me talk a little bit about this investment really in sense of long-form courses, but also a plan to develop tacit knowledge. This thing that sometimes people call carpentry in some places, that you're talking about in terms of coding skills, this implied knowledge that we have to make the implicit explicit if we're going to help these students move ahead. And we've taken a slightly different approach. Meaning, this is a course that I developed in the first year. It's matured over the past few years. And as you notice here by the unit titles, it's focused on problems in biology. Are mutations dependent or independent of selection? Right? What are the mechanisms by which a genetically identical cell can nonetheless have different outcomes? Can we think about how individual cells or organisms sense or move in their environment? And this extends not just to things like E. coli, but to larger organisms that locomote, and we look for common principles. How can signals be filtered or turned into excitations, whether we're talking about a neuron or cardiac cells, and then moving to large-scale systems where we look at questions of how feedback between predator and prey or parasites and hosts or across organisms that might be sharing public goods can lead to emergent behavior and then even consequences at larger scales. So by doing this, there's a little bit of sense. I know people are not viewing the modeling like the pill that you slip into the dog's food so that the dog takes it down if you've ever taken care of a dog who's sick. This is obviously we want these things to both be valued, but we are using the appropriate models in the convergence sense because the problem demands it, not because this is the standard set of models and we're just looking for a convenient example. So in doing so, we really span these scales, as I say, from molecular and cellular bioscience, reading papers, looking at these data sets and trying to build appropriate models to things like organismal behavior and physiology and large-scale systems, including these populations, communities, flocking systems, and so on. In the process, when we get to the end, we've taught them a lot of things, right? But we've taught it in an order in which these are building upon each other, and there is a sense of dynamical systems, whether it's stochastic or continuous dynamical systems, both on the theory and the computation side, is perhaps the thread that links all of these together. But nonetheless, there's a variety of methods that they are learning precisely because now they not only have learned the method, but they've learned it in concert with a purpose. And for most biologists, that is the reason for them to actually put the time in. Without that in the abstract, they're probably not going to put the time. Right? And for many of the physicists and the mathematicians, this is the first time they've really seen these together, and they sort of realize, I don't need to go down that rabbit hole of asymptotic analysis because it's totally non-bearing to what we're trying to do in the real world or in the data set. And so in each week, what we try to do is introduce a biological problem, translate, think mathematically, I would say transcribe here, think algorithmically, and then use the homeworks as a way to get more insight into this biological problem, really inculcating a quantitative mindset and not just offering a gateway to a quantitative tool set. And just to point out that, yes, I'll do a little plug here for a book that should have been done, but with COVID, I'm a little bit delayed, but it's nearly done. It is a book that covers those topics, but also has code, but it's outside the book. So the book is really a book about the dynamics of cells, organisms, ecosystems, and yet there's a computational guide that goes with each chapter. And frankly, that laboratory class has been the key to deepening the knowledge of the students and preparing them for their rotations and their research. I'll point out that now we've translated this from MATLAB to Python to R. So we have 3 different versions of this laboratory guide. If anyone's interested in evaluating this in 2021, it'll be ready in January for evaluation and hopefully publication sometime about a year after that. And it's really aiming at improving tacit knowledge for computational analysis of living systems. It is different and distinct from what Stefano's getting at, which is really core computational skill sets that biologists need to know. These are about these systems. It's all as a means to understand these particular living systems. And I hope that these kinds of courses become the gateway for a broader range of people to become quantitative bioscientists in the same way that terrific biophysics books or math bio books or computer science book becomes gateway for those particular interfaces. I think we need a broader view if we're really going to bring people into this field. So I'll go in my last, I think, 5 minutes or so I have here to just these 2 sections on relationships and also a sense of place, because relationships do matter if you're going to build such a program. And I'll just start with this image, which is one of the first things we did early on was find a physical space. I know in COVID, where nothing matters, but a physical space which they eventually can get back to, where when they arrived, there was a home, that they shared an office and could interact and have a sense of community. And rather than putting them carols in each of their different disciplinary programs, to bring them together. And in that first year, they really do build a sense of a cohort. And then when they go off, the next cohort comes, but then there can be inter-cohort interactions. So what we've tried to do is build this cohort through many ways by having some shared things, even recognizing their differences. A foundations class, a seminar, and a helping writing class. We've seen then this research span multiple scales. The community has built for itself features. They have their own Facebook page. They have their own student association. And so they've created something where now they have a peer-to-peer community. And we also, and sorry for the fuzz here, I'll show a higher resolution version in a moment, they also get engaged in teaching the community, other biologists who are not in the program, how to do a taste of QBIOS in an annual workshop that we started in the first year and that continues to this day. And as I said, we have our first alum and more to come. Some of these features mean that we felt we wanted to get inter-cohort discussions, but rather than me organize it, the students last year, and we've had to push this back to next year because this happened just as COVID began and things shut down, but we got at least a few off the ground. The students created a way that the fourth-year students would talk to the whole community, and the first-year students had to be there so they could see some of what was going to happen in the future. As I said, we've also organized these workshops where, again, we reach out to a broader community and teach them, where the students act as instructors, reinforcing what they've done and broadening the impact and their sense that they've moved on just from the student phase now to that transitional phase where they're an expert and they need to share some of it back to the community. And this is something where I can't believe I'm showing you an org chart, but I want to show this just for a moment, which is if you really want to pull this off, you're going to have to think about relationships between yourself, your program coordinator, your graduate committee, the student government association, the students. And this was when I was supposed to be on leave this year, but that got canceled. I'll go next year. But I think it's very important to understand who you're reporting to, what are the lines of communication, and I can't overemphasize enough the importance of the program coordinator as a partner, and I will thank her at the end. Lisa Redding has been terrific, but really needing a dedicated person if you're going to build something of this structure. You need to think of that even when you're small, because you will need to have it as you grow. So the last thought I have here is just a brief one. It's about a sense of place. And when we first made one of our early slides, we tried to have it so even if you don't see the words, you had a sense of what we were up to. That all of our messaging and our communication showed that we cared about moving across scales and about integration. And you can see that by just seeing our examples means that we have valued those particular examples as being things that can be part of a QBIOS experience. And when I look at the landscape now 5 or 6 years past, when we first started developing this program in 2013, this is a slide that literally I took off from some of the originating documents, where Rice had just started their program, Colorado had just started one, I had visited some folks who they had just started, the Princeton one, now it's a decade old, was only a few years old when we first started planning this. I made the argument that if we were going to be a top 10 program, because there are only 8 other programs, and of course I realized that is not exactly true, that there's some different variants of that, but the space here is not that big yet. And frankly, I think that's unfortunate. I would be delighted that all of us, in some sense, were at a more friendly competition, because that means that there are more of these programs, both at the undergraduate and graduate levels, that create really an atmosphere nationally where thinking about graduate program at this interface does not become an exceptional thing or on the side, but really becomes core to how we study and think about living systems. So to the extent to which what we've learned can be helpful to others who want to move forward here, that really has been my goal today. And I think that, frankly, one of the reasons I was excited about this early in the year is the extent to which this conference and these discussions and just opening some of this up at the graduate level can help accelerate that process, like it's done, I think, for the undergraduate level. And with that, I just want to thank a few folks. Critically, Will Ratcliffe and J.C. Gumbard, who have taken on more leadership roles in the past year, especially as I'm about to go for at least next year on sabbatical in Paris and then return. Also, Lisa Redding, who has been a partner from the outset. She has been critical, a delight to work with. I know you don't know her, but she's great. And I think just to emphasize the importance of staff who care about these programs, especially interdisciplinary programs, because you're really developing it together. And of course, in addition to all the students, faculty, and administrators who help make it go, but also the graduate committee, who has taken on really on a voluntary basis. I'm not chair, right? This is all voluntary work where we've decided out of a shared commitment to try to make it happen. And with that, I'm happy to take questions along with, I think we have a short question period for this and the other programs.
Thank you, Joshua. Appreciate that very quick summary of what I know has been a tremendous challenge to develop over many years by you and a whole bunch of other folks there. So let's see. I see Chad Brazil had his hand up. So Chad, why don't you go ahead?
Yeah, I was wondering about potential trade-offs for graduate students being in this program versus their disciplinary programs, your perspective on that. And interestingly, on maybe what views faculty had when this was being put together, and now that it's played out, has that perspective changed? Yeah,
so I think at the outset, there were certain colleagues, some of whom are now some of the biggest supporters of the program, who were quite skeptical that this was going to work. A few colleagues in physics remind me that they said this is not going to work, that the students were just not going to come, and he was very wrong, and now he takes about the most students as anyone in the program, and partly because there's a number of undergraduates who come up through a disciplinary program but actually don't want that precise discipline anymore. They've heard about interdisciplinary work. They're seeking something different. In physics, that might mean someone who doesn't want to take quantum field theory as part of the canon just because that's what everyone has had to do, but really wants to work at an interface. And yet those interface people are valuable in these teams. So now the faculty are beginning, I would say, building a portfolio of different kinds of people in their groups. So for a person who really wants to make a contribution to their discipline, whether that's on the bio side, someone who doesn't necessarily want to do the coding or the mathematics training, then it's probably not the right training program for them. They'll benefit from that person in the group, but we're not saying this is going to be the precisely right fit for everyone. Likewise, in mathematics, if you want to go off to be a professor of math, one of my colleagues who may be here reminded me that a QBios degree may not be the right way, and I will defer to more conservative members of math departments, some of whom may not want that, and some in biomath may want that, and that may change in a 10-year period, but certainly they're going to depend on both the student and the faculty member. We've had students now come in through every one of our home schools except for psychology, so we are seeing participation. The strongest participation are bio, physics, and then math.
Okay.
In that order.
Thanks, Josh. Let's see. Shinhan Shu has his hand up. So,
hi, Josh. So I just have a question about. Can you comment on the campus culture in Georgia Tech compared to other universities, as you understand? Because one thing I found challenging is we try to run the interdisciplinary graduate training program through funding NSF NRT program. The challenge has been trying to get the non-bio faculty to chip in and sign up to this interdisciplinary interests and goals, because there's so many interests. So is Georgia Tech fundamentally different from many other institutions, or you have some way of coaxing people into the program?
So, right, each program will have a little bit, you've brought a couple issues. First, participation, and then funding calls, and I think those are slightly different. With respect to NSNF NRT, I'll just put it out there. We tried a few times and we got close once, but we did not get funded. In our NSF NRT, we did connect across with computer scientists and engineers to try to broaden that skill set. And we have now some other approaches to trying to secure funding for this program. But again, bridging across the gap, essentially building upon what we've done here, but then looking to data sciences as a way to interface and help people on that side get more bio training, and for us to get an expanded work on the data science side. Keeping in mind, though, we did make an intentional choice that at present the program faculty are only within the sciences. And in part, Georgia Tech's engineering is so big that we felt it was critical to build a culture of science in this interdisciplinary program to complement existing bioengineering and bioinformatics programs. But if those don't already exist at your university, then a computational and quantitative bioscience program might be the right language or approach. There's other ways to make it work, and it's going to have to fit within the pre-existing landscape of the university. But there's no barrier per se to get people. People tend to be very collaborative across disciplines here when deciding to try to write these training grants. We haven't had any problem on that side of getting buy-in.
Great. Let's see. Corinne had a comment. Corinne, do you want to unmute ask?
Oh, yeah. It was just about how the funding works for your graduate students, at least in the first year. I imagine they're covered on grants in the second year once they choose an advisor. But I think this is a problem when you're first starting interdisciplinary programs, is like, how do you fund those students in the first year if you don't get some serious buy-in? So I'm just wondering what you did in your program.
So one of the things that we tried to do from the very outset was to decide what was most important to us given the limited amount of funds that you have when you're vaporware, like when you don't exist. And also not being a department, there is a stress point there. So the way that we've worked is that we have a funding program that basically, like other schools, departments in the College of Sciences, focuses on the school as the support mechanism, but the program, I decided instead of arguing for top-up fellowships, to give every student a summer graduate research assistantship, because I wanted the money to go to the student in the event, which ended up happening, that they didn't quite place in a rotation. They weren't dependent on funds in order to make the placement. So most students are supported by a GTA in the fall and nominally by a GTA in the spring, but we've managed to pull together different internal funds to make it work in the spring. So effectively in the spring, they're in a GRA, and in the summer, they're in a GRA in the program. And by that point, they're supposed to be placed with an advisor. And then it's the student advisor department's responsibility, like in other programs, to support. Obviously, a training grant would help. There are not enough training grants around in this space. There just aren't. We are trying again, but I will say just not enough.
Okay. All right. Thanks, Josh. So I think we should open this up now to questions for Stefano or for Josh.
Can I address one thing? Because I saw in the chat.
Yep.
A few things. Is that okay?
Oh yeah, sure. Let's see. I can
go very quickly through some of them. I don't want to steal from Stefano. Just very briefly, there are 2 points that were raised I wanted to address. One of which is, Sharon, you're absolutely right. There's a biomath grad program. There's a lot of biomath graduate programs, but we're not a math program. Again, my PhD was in physics, and there's a big landscape of biomath. I felt we were doing something a little different in trying to frame the program. So we did talk about that in framing. It is something quite different, and there's a much deeper history there. Just to point out, I didn't mean to disrespect the biomath programs, but we're trying to aim a little bit differently. And then the other issue that I wanted to also raise that I think is an important one that Alan raised, I don't want to avoid it in the chat. He wrote there was a gender imbalance in the student group Josh put up. Serious issue. Okay, I'd like to talk about that. When we first started, we made a serious intentional effort to reach out to HBCUs, institutions that serve disproportionately minority, underrepresented groups. And there's also the law of some small numbers here. At present, out of the 34 students plus one graduate, we have 11 women. And we've had, unfortunately, some folks, not just women, but a few people have had to leave due to some personal issues unrelated to their progress in the program. On top of that, we have one African-American male and I think 4 or 5 Hispanic students. At some level, with respect to what my expectations were in quantitatively focused disciplines, there's some level at which we are majority minority, and some ways in which we have a way to go. It's something that certainly was on the mind of the graduate committee. I am proud of the folks who have decided to come, in the extent to which I do think we have significant diversity, just not in the output, but actually in our process of valuing the recruiting methods that we take to try to reach out to influencers, to target folks, and to value that throughout the process. I'm happy to get more feedback, but it's something that I think any small program, we've decided in that first year, like we got 2 out of 9, but then a few years later, we got 6 out of 9 were women. So there's some small numbers. We felt we had the right path. We talked about it a lot that first year, but we felt that we were going to be on the right path, and I think we are. Always room to improve. I just wanted to make sure address that point.
Okay. Yeah, there were several other things in the chat, but I want to make sure that if there are overarching questions for both Stefano and and I actually have one because I think it applies to both of your cases, and that is really bringing together very different faculty, whether it's a program or whether it's a structured process. How did you actually effectively do that without the infighting that can arise? Do you have any suggestions for those of us at institutions where faculty really are siloed in very different ways and may not, they may want to write an NRT together, but they aren't there yet? So that's to both Stefano and Joshua.
Yeah, for like Chicago, like what we have are that biology is really divided into several departments and several graduate programs. And so I feel that in a way it was actually welcome to have something that would unify all these different programs, at least at the beginning. Of course, that doesn't mean, that everybody were on board, because that's never the case. When you have more than 3 faculty, it's basically probability 1, somebody will dissent. But we were able to build enough consensus to give it a crack, and then shared extensively, like the feedback, the surveys, the data with everybody. And I went, because I'm also like the director of a graduate program here, I would go to the meeting of the graduate programs and present this data and talk extensively about this. And so I think either because they didn't want to hear about me anymore, or because they were finally convinced, little by little, I think we kind of won these resistances that were definitely there. Also because like we were proposing something fairly involved, expensive, like time-consuming, and of course you could have multiple ways to spend the same time or money or effort. So it's completely understandable. But that's my view.
Yeah. I just want to point out that I think that this notion of conversations is important. People don't like surprises, so you have to go out and make those forays essentially to department. And I did something similar. I assume people on this call who've built these programs have done the same thing, reaching out to each department. At least at Georgia Tech, because we're a technical minded institution, there was a sense that a quantitative bioscience program made sense. It just had a sense that it was the right kind of program for our institution. And because we had a pre-existing bioengineering and bioinformatics program, there seemed to be a missing gap there. Right, so there was some sense that people thought, okay, it made sense, but really to get it across the line means at some point chairs are worried, does this mean less money for my graduate program? Right. And deans are concerned that this, again, it's a zero-sum game. At some point, there has to be a critical mass of faculty who say, we're behind this. And then it's harder for the chairs to say no and harder for the deans to say no. And at the end of the day, the reality is that many people may sign up, but the affiliation, strong affiliation, Ian Kuzin has a wonderful paper on leadership and a small number of influencers and other people who say, like, okay, that's fine. You do need a small number of folks who are willing to say, I'm behind this to make it go, to get it out of that sort of zone of death at the outset. Once you're past that, then I think it's people are happy to join along and then eventually see, is there something that they could benefit from? But at the outset, you have to make sure that the faculty see, I might get a new kind of student, help to contribute to a new kind of community that reflects me and my background. And since it's supported by BWF, we have multiple BWF career award at the Scientific Interface Fellows, former fellows in our program. So there are already people who are in that mindset. So we had that momentum. You have to identify those people early as allies.
Thanks. I see Kristen Powell's put a comment in the chat. Kristen, do you want to unmute and say something about it?
Oh, sure. I mean, most of my thoughts sort of back up what Josh is saying, I think. But the way we got buy-in from the start was taking a slightly different approach by doing a certificate model. And that has its own challenges, but that sort of appeased faculty who had strong concerns about the students not getting their deep disciplinary training, while still providing the students their interdisciplinary training. And even though we were worried about that time to degree issue that Josh talks about, we've had enough, about 30 graduates at this point, that we can do the math and we see that we've never added time to a degree beyond what's average to a department. And I think that's because often what happens is the students' degrees get flipped. So in year one, they sort of do, instead of doing their core coursework in a discipline, they do their interdisciplinary coursework or their quantitative coursework. And then in year 2, they go to their discipline, their department, and do their disciplinary coursework. And so instead we see, instead of that adding to time to degree, that we actually just have students sort of flipping the order in which they're taking different coursework.
Okay.
And then, of course, the other way to get incentive or buy-in is just money. So it's been a challenge to fund these programs, but like Josh said, is we try to do it from a variety of different ways, and then we try to provide funding for the students in year 1, and then give some sort of smaller fellowships into year 2 that help out the departments as students transition in.
Okay. So I do have some other sort of general questions that may apply to many of you in terms of thinking about these programs. It's about time for a break, though, and I want to make sure that we sort of stay kind of on time. So